let's evaluate 2x minus y squared over the triangular region that's enclosed by the lines y equals negative x plus 1, y equals x plus 1, and y equals 3. Well, to get a hand on this, the first thing we need to do is produce a graph of this so we can get an idea what we're talking about here. Let's see, y equals x plus 1. That's kind of easy. That's going to look like this. That's y equals x plus 1. Y equals 3 is even easier. See, that's 1, 2, 3. So it's going to be a horizontal line. And then y equals a negative x plus 1. That's going to look, well, the triangular region is just going to look like that. So this piece right here we don't need. This we don't need. So here's the region that we're talking about. Now this value over here has got to be negative 2. This value here has got to be 2. And let's see, I'm going to label that. And this is a line y equals negative x plus 1. Now, when I'm looking at this, I can see right away that I could do this as either a type 1, type 1 region, or a type 2 region. So what I'm going to do first here is I'm going to do this as a type 2 region. So to do that, first thing I need to do is think in terms of what are these lines as x as a function of y. Well, this one will give me x equals y minus 1. This is still going to be now the vertical line y equals 3. And this is going to be x equals negative y plus 1. So what I want to do is I first want to integrate in this direction. And then when I'm done with that, I'm going to integrate essentially in this direction. So my double integral, the outside one, this blue one, is going to go from 1 to 3. And then the inside one is going to go from here, which I would write as 1 minus y, to y minus 1 of the surface that I'm dealing with, 2x minus y squared. And this is going to be in the order dx dy. So I'm going to take this first piece and work with that. So I'm going to take the integral 1 minus y to y minus 1 of 2x minus y squared dx. That's going to be equal to x squared, because x squared over 2, the 2 is going to cancel, minus y squared x evaluated from, 1 minus y to y minus 1. So that's going to give me y minus 1 squared minus y squared times y minus 1. That's the first piece. Minus 1 minus y squared minus y squared times 1 minus y. So now I'm going to expand this, collect like terms, and see what I've got. See, this will give me what? Y squared minus 2y plus 1 minus y cubed plus y squared minus, see what's over here, 1 minus 2y plus y squared minus y squared plus y cubed. Well, obviously, I'll get rid of those right away. And see, that's going to be, I'm just going to write the whole thing out again. Y squared minus 2y plus 1 minus y cubed plus y squared. Now move this negative in. Negative 1 plus 2y minus y cubed. Now I'll start collecting like terms. I've got 2 negative y cubes. Oops. Cubed. You see my constants are going to go away. Negative 2y, positive 2y is going to go away. And I have plus 2y squared. So now I need to go ahead and integrate this with respect to y. So now I'm going to look at the integral from 1 to 3 of negative 2y cubed plus 2y squared dy, which is negative 2y to the 4th over 4. So give me a 2 down there. Plus 2y cubed over 3, evaluated from 1 to 3. So this is negative 3 to the 4th over 2 plus 2/3 times 3 cubed minus, evaluate at 1, I'll get a negative 1/2 plus 2/3, which when you fiddle with this and actually evaluate it all, do all the arithmetic, you'll get negative 68 over 3. Now that answer is negative, which means we cannot interpret it as a volume. So let's go ahead and take a look at the graph and see if that makes any sense. So here's the graph of this surface. And by looking at it, you can see it. Here's the xy plane. It does look like the majority of it is below the xy plane. So I'm going to add a few more things in here. I'm going to put into this, I put a bunch of stuff, so I'm going to put D, E, and F. And what that is, whoops, need a comma right there. What that is that's this triangular region that we're talking about. See, if I look straight down there on the xy plane, here's x, here's positive y. Here's that triangular region. So when I look at that triangular region, as it's over top of this surface, it's pretty clear that it's all below this triangular region. This part that we're integrating, this region, the surface is all below there. And you can throw in this B if you want, which is just the xy plane, or at least a piece of it. So there's the xy plane, and where it cuts the surface that we're integrating. So the whole purpose of just doing this is just give you a quick look at what's going on here. You can see that the volume as such is definitely negative. It's all below the xy plane.